So this is the chapter 8, classwork number 6, synthetic division worksheet number 1. On this, what we're doing is we're using a method called synthetic division to find the roots. And so what we're going to look at to figure out what numbers to try and use for our synthetic division is what we call P over Q's. These are going to be our possible rational solutions. So my constant is where I find my P's. And those are going to be plus or minus. And we're looking at things that multiply to 7, factors of 7, things that go into 7. So I'll be plus or minus 1 and plus or minus 7. Then my Q, I'm going to find by looking at the coefficient, the Lie coefficient. And so the Lie coefficient is a 1. And so the only options for my Q are going to be plus or minus 1. So what we do is we take those P's over Q's and we take all of the P's, plus or minus 1, plus or minus 7, and we put them all over all of our Q's, which are plus or minus 1. Now, in this case, anytime your Lie coefficient is a 1, all of your P over Q's are going to end up being integers, not fractions. So I'm going to take my positive and negative 1 over positive negative 1, and my positive negative 7 also over positive and negative 1. So 1 over 1 is going to be 1. I'm going to have either a positive or a negative 1. 7 over 1 is 7, so I'm going to have a positive or negative 7. Those are the only possible rational solutions. And what that means is if I have rational solutions, not radicals, okay, which are irrational, not imaginary or complex numbers, but whole numbers, integers, or fractions, it has to be either a 1 or a negative 1, a 7 or a negative 7. No other number that is rational will work. So what I'm going to do is I'm going to start with trying the number 1. For this first one, I'm going to be doing this first assignment. I'm going to be doing separate little synthetic divisions. On the second assignment, worksheet 2, I'm going to be doing it in a table form. So what I'm going to do is I'm going to start with trying the number 1. And then I'm going to take the coefficients in front of each of these numbers. So 1, 1, negative 7, negative 7. So I'm taking all my coefficients. And if I want them in descending order, if I'm missing a particular term, I'm going to make sure I put a 0 to hold its spot. So again, I'm going to have a 1, a 1, a negative 7, and a negative 7. Okay, I'm going to drop down my 1. Always drop down whatever your first number is. Okay, so, and then what I do is I'm going to take 1 times 1 is 1. I add this and I get 2. 2 times 1 is 2. I add these and I get a negative 5. Negative 5 times 1 is negative 5. I add it and I get a negative 12. So what I'm looking for, this number here is our remainder. I want my remainder to be 0, which means that I found a factor. Okay, so in this case, when I put a 1 here, I was really dividing by an x minus 1. That's really what I was doing because 1 makes x minus 1 0. So this 1 ended up not giving me a remainder of 0. If I was to substitute 1 into this polynomial, 1 cubed is 1, plus 1 squared is 1, minus 7 times 1 is negative 7 minus 7, and a 1 minus 1 minus 7 minus 7, I have a 1. Oh, sorry, that's a plus 1. Sorry, 1 plus 1 because it was positive. So I have a 2 minus 14. I get a negative 12. So this synthetic division does 2 things. If I wanted to substitute 1 into this polynomial, I would use the number 1 here, do synthetic division just like I did. Whatever remainder I get, that's what I would get when I substituted 1 in. So this is really saying when I do P of 1, substituting 1 into that polynomial up here, I get a negative 12. Now we are trying to find zeros, okay? Solutions, we want our polynomial to equal 0. Which would have meant that if this had made a 0, then this x minus 1, which would have given me a 1 as a solution, would have been a factor. But x minus 1 is not a factor because I got a remainder. Something just kind of as a side note, what this means is, again, if I use a 1, I'm really dividing that polynomial by x minus 1. If this was a degree 3, we call this depressed polynomial, is going to be 1 degree less. So this would have been an x squared plus 2x minus 5 minus 12 over x minus 1. That's the polynomial I would have gotten if I was dividing by x minus 1, whether I used long division or the synthetic division. Okay. Now, on this worksheet, we're not using it to physically do the division. We are using it to find our solutions. Let me just get rid of this so I've got more space. So 1 is not a solution, okay? And x minus 1 would not have been a factor. So let's see, let me try a 7. Let's see what happens with 7. So I have 1, I have 1, I have -7 and a -7. Okay, I bring down this 1. 1 times 7 is 7. I add these together, I get an 8. This is not looking like it's going to work. 8 times 7 is 56. I add that together, I get a 49. I'm definitely not going to get a 0. Let's just see. 49 times 7 is 343. Minus 7, when I add my -7 and 343, I get a 336. Just kind of another note. If I am using a positive number for my synthetic division and I get only positives back, that is something that we call an upper bound. And no number higher than 7 would work. So if I had other choices, which I don't here, but if I had other choices, this is an upper bound. This is a polynomial, and it's a degree 3 polynomial. So really, this polynomial is going to be going down forever on the left side and up forever on the right side. I'm at the up forever right here. Okay, it's not going to come back down. That's what this is telling me. It's going to just keep getting bigger and bigger and bigger as I try other positive numbers higher than 7. Okay, so let's go the other direction, and let's say I try a -1, and I have 1, 1, -7, -7. I bring down my 1. -1 times 1 is -1. I add these, I get 0. 0 times -1 is 0. I add these, I get a -7. -7 times -1 is 7. I add and I got a 0. So I found a solution right now. X equal -1 is a solution. It is a root. It gave me a 0. Side note, what would have given me a -1? A factor of x plus 1. So I was really dividing by x plus 1. And when I divide by x plus 1 gave me a remainder of 0. It actually gave me x squared, because again, it was degree 3. So whatever I get left with is going to be 1 degree less. It's an x squared plus 0x, which I don't need to write the 0x, minus 7. That's what I would have gotten if I had divided by x plus 1 using long division or synthetic division by using a -1 here, because -1 makes this 0. Now, since I have a degree 2 left over, I can solve a degree 2. When we have a degree 3 polynomial, we need to get 3 answers. I have 1 answer. I need 2 more. This is going to give me 2 more answers. I'm going to add 7 to both sides. I'm going to square root, and I get a plus or minus root 7. These are my other 2 answers. These are irrational. So I would never have found them continuing the synthetic division. So it's important that once I find a 0, I take that depressed polynomial and I use that to then solve for the rest of them. So my solutions, let me just write them out. X equal -1, X equal a positive root 7, and X equal a negative root 7. Those are my solutions. So on number 2, again, we're going to be looking at the P over Q's. This is going to be our P. This is going to give us our Q. So our Q, again, is going to be a positive or -1 because there's a 1 as a lead coefficient. Our P is going to be a plus or minus 1 and a plus or minus 5 because that's what multiplies to 5. So for our P over Q, I'm going to have plus or minus 1. Hold on, let me just. Plus or minus 1, plus or minus 5, both over plus or minus 1. So that is going to give me a plus or minus 1 and a plus or minus 5. So those are the 4 that I am going to try. So let me start with a 1. And I have 1, 5, -1, -5. I'm going to bring down my lead coefficient here, my 1. 1 times 1 is 1. Add, I get a 6. 6 times 1 is 6. I add, I get a 5. 5 times 1 is 5. I add, I get a 0. So I got this one on my first try here. So this right here giving me a 0 means that this is a solution. So one solution is going to be X equal 1. And again, the factor that would have given me this, or what I really divided by, was really the opposite X minus 1. Okay, but my solution is going to be X equal 1. So I started with a degree 3. Once I get a 0, this is now a depressed polynomial, we call it, and it's 1 degree less. So this is really x squared plus 6x plus 5, and I'm going to set that equal to 0 and solve. And I can factor that. I'm going to get an x plus 5 and an x plus 1. So another answer is a -5 and a -1. Notice all 3 of these are from our possibilities. So let me just list it out. So again, I had x equal 1, x equal -1, x equal a -5. Those are our 3 solutions. On number 3, this time I have a degree 4 polynomial. So I'm going to have 4 solutions. So what's going to happen with this is I'm going to have to do synthetic division twice. Once to take the 4 down to a 3, and then I'm going to take that 3 down to a 2, which would be a quadratic that I can solve just by factoring or quadratic formula or completing the square. Looks like for this one, I'm going to have the same P's and Q's. So my P is going to be plus or minus 1 and plus or minus 5. And my Q is going to be plus or minus 1. So again, P over Q, positive -1, positive -5, all over positive -1. So when I take each of these over 1, I get plus or minus 1, plus or minus 5. So for this one, let's say I start with a 1 and let's see what happens with that. And so I'm going to take my coefficients 1, -8, 18, -16, 5, making sure it's in descending order, making sure that I have a 4th, a 3rd, a 2nd, a 1, and then this would be degree 0, making sure I have everything. If I was missing anything, I would put a 0. So I'm going to have a 1, a -8, and 18, a -16, and a 5. Bring down my 1. So 1 times 1 is 1. I add, I get a -7. -7 times 1 is -7. I add, I get an 11. 11 times 1 is 11. I add, I get a -5. -5 times 1 is a -5. I add, I get a 0. So I got a 0 when I used x, when I used 1. So x equal 1 is a solution. So now it was a degree 4. This depressed polynomial is now going to be a degree 3. So I'm going to use the 1, -7, 11, and -5. And I'm going to do another synthetic division. Now, if 1 worked before, it could work again. Okay. Let's say that I try a 5. Let's just see what happens with 5. Bring down my 1. Okay, bring down my 1. So 1 times 5 is 5. I add, I get a -2. -2 times 5 is -11, sorry, -10. I add, I get a 1. 1 times 5 is 5. I add, I end up with a 0. So I ended up with another 0 right here. And so another answer is going to be x equal 5. So now I'm going to take the polynomial I just got, which is now a degree 2, x squared minus 2x plus 1, and I'm going to set that equal to 0 and solve. So this is actually going to be x minus 1 squared. It is a perfect square trinomial. So I'm going to get x equal 1. I'm actually going to get it twice. Okay, so I get this, and it's really a double. So I have 4 answers, but one of them, well, actually I end up with a triple because I end up with this twice here and I had it here. So I actually ended up with an x minus 1, which is going to be a triple and an x equal 5. And so I do have 4 answers. 3 of them are 1 and 1 of them is 5. On number 4, let's again look at our Q and our P. So this time my Q this time is still going to be at plus or minus 1. My P are things that multiply to 6. So that's going to be a 1, a 2, a 3, and a 6. All of these are factors, okay? Because 1 times 6 and 2 times 3 both will give me 6. So my P over Q is going to be, again, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1, which is going to basically give me a positive negative 1, 2, 3, and 6. So I have those to try. So let's say I start with a 1 and let's see what happens. So I have 1, -1, -5, 3, 6. Bring down the 1. 1 times 1 is 1. I add, I get a 0. 0 times 1 is 0. I add, I get a -5. -5 times 1 is -5. I add, I get a -2. -2 times 1 is a -2. I add, I get a 4. So this remainder of 4 is really saying that right now at 1, 1 comma 4 is a point on my polynomial. So I'm 4 above the x-axis. I want to be on the x-axis. So let's see. I'll try 2. Let's see what happens with 2. Okay, so bring down my 1. 1 times 2 is 2. I add, I get a 1. 1 times 2 is 2. I add, I get a -3. Negative 3 times 2 is negative 6. I add, I get a negative 3. Negative 3 times 2 is negative 6. I add, I get a 0. So I found one of these. I got a 0 when I was using 2. So x equal 2 is a solution. So I'm going to take this degree 3 depressed polynomial, and that's what I'm going to try now. 1, 1, negative 3, negative 3. The one thing I'm going to say is I now have a new, my P is still, my Q is still the same. My Q is still 1. But my P is now a negative 3. Now what happens is I never add new ones on, but sometimes I can take some off. So I'm not going to have a plus or minus 6. I'm not going to have a plus or minus 2. The positive one I'd already tried and that didn't work. So if it didn't work before, it's not going to work again. So really I have a negative 1 to try, a positive 3, and a negative 3. So let's say I try the positive 3. Let's see what happens. I bring this down, I get a 1. 1 times 3 is 3. I add, I get a 4. This doesn't look like it's going to work. 4 times 3 is 12. I add, I get a 9. 9 times 3 is 27. I add, I get a 24. So again, something to look at. When I have a positive number here, and I get all positives back in this depressed polynomial, again, this is an upper bound. That means I wouldn't have tried that 6 because anything higher than 5 is not going to work. I'm at the point where the graph is going up forever. So let's go the other direction. Let's try a negative 1. If that doesn't work, I'll try a negative 3. So I have 1, 1, negative 3, negative 3. Bring down my 1. 1 times negative 1 is negative 1. I get a 0. 0 times negative 1 is 0. I get a negative 3. Negative 3 times negative 1 is a 3. I add, I get a 0. So I ended up with another 0. This one is x equal negative 1. Now I'm going to take this depressed polynomial here, which is now degree 2, and I'm going to solve that. So I'm going to solve x squared plus 0x minus 3, set that equal to 0. Add 3 to both sides, take the square root and get a plus or minus root 3. So my 4 answers, okay, I had x is equal to 2, I had x is equal to negative 1, I had x is equal to root 3, I have x is equal to negative root 3. Those are my 4 answers. On number 5. So number 5 is slightly different because this time my Q, I apologize, is not a 1. So this time my Q is going to be a positive negative 1, 2, 3, and 6. My P is also a positive negative 1, 2, 3, and 6. So when I do my P over Q this time, I'm actually going to get fractions because my Q does not have to be, my denominator does not have to be a 1. So I'm going to take a positive negative 1 and a 2 and a 3 and a 6. And I'm going to put those over each of these denominators, over a 1, then over the 2. Let me do it this way. I'm going to put it over the 1. And when I put it over the 1, I'm going to get a positive negative 1, positive negative 2, positive negative 3, positive negative 6. I am also going to put it over the plus or minus 2. So when I do that, I'm going to have 1 over 2, which is going to be a 1/2. 2 over 2, which is a 1. 3 over 2, which is going to be a 3 halves. 6 over 2, which is a 3. Again, I have a 3 already. Then I'm going to put it over the 3. So when I put it over the 3, I get 1 over 3. So I get a 1/3. 2 over 3. So I have a 2/3. 3 over 3 is a 1. 6 over 3 is a 2. I already have 1 and 2. Then I need to put this over the 6. So 1 over 6. So I'm going to have a 1/6. 2 over 6 is really a 1/3, which I already have. 3 over 6 is a 1/2, which I already have. And 6 over 6 is a 1. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, plus the negative, so 18 to try, which seems like a lot, but it's not a lot compared to an infinite amount that I could try if I did not list these out. Okay, so I am going to have and I'm going to start with a 1, and let's just see what happens with that. So I'm going to have a 6, a 7, a -36, a -7, and a 6. I'm thinking I might have to go higher because I need to somehow get that 36 down, but let's just see what happens. 6. Okay. So 6 times 1 is 6. I add it, I get a 13. 13 times 1 is 13. I get a -23. -23 times 1 is -23. I get a -30. -30 times 1 is a -30. I get a -24. Now, something I'm going to say is when I am looking at this polynomial, if I put 0 in for all my x's, for each of these x's, to see what happens when my x is 0, I would get a 6. I would get this 6. At 0, I am 6 above. At 1, I am -24 below. There is a solution between 0 and 1. Maybe it's one of these maybe it's this 1/2 or this 1/3 or this 2/3 or this 1/6. Or maybe it's not. So at this point, what I could do is I could keep trying these and see what happens. But I do think that maybe it's going to be one of these fractions. But let me just keep going and kind of see what happens. Let's say I do the 2. Let's say I just keep it with the nice numbers right now. So 6, 7, -36, -7, and 6. Bring this down, 6. 6 times 2 is 12. I get a 19. 19 times 2 is a 38. This is looking promising, a little more promising. I'll bring that down to 2. 2 times 2 is a 4. That gets me a -3. -3 times 2 is a 0. I mean, sorry, a 0. I'm going to get a 0. It is a -6, and I'm going to get a 0. So I do have a 0 when my x is 2. So x equal 2 is a solution. I'm going to take this depressed polynomial, and I'm going to keep going from here. So let's say I take 6, 19, 2, and -3. And what you'll notice is your Q is still the same. So all of these are still going to be the same, but our P is now a -3. So since my P is a -3, that means I'm not going to have the plus or minus 2, and I'm not going to have a plus or minus 6. So let's say I try a 3. I'm not thinking a positive 3 is going to work, but let's just see what happens, okay? I bring this down, I'm going to have 6. I multiply, I get an 18. Yeah, this is going to start getting bigger. I'm going to get a 37. 37 times 3 is a 111. I'm getting a 113. This is definitely not going to work. I'm going to just continue working it out. I get a 333. Whoops. Sorry, I don't. I was times in that by the wrong one. 113 times 3 is a 339. 339, so I get a 336. Okay, what's again, you'll notice this was a positive, and I end up with all positives back. There's no way that this is going to start going down. So again, this would have been an upper bound. Okay, now I knew I couldn't try any of the higher numbers like the 6 because this was a 3. Okay, my new P was a 3. So let's go the other way. And I think what I'm going to try to do is I'm thinking that since I have a negative at negative 24 and a positive when it was a 0, I'm sorry, a negative 24 when it was a 1 and a positive 6 when it was my 0, maybe I'll try that 1/2 and let's see what happens. So if I try a 1/2, 6, 7, negative 36, negative 7, and 6. They bring this down 6. 6 times 1/2 is a 3. 3 plus 7 is 10. 10 times 1/2 is a 5. Bring that down, I get a negative 31. Half of 31 is not going to be nice, so I'm thinking that it's not going to be my 1/2. I could try a 1/3 or a 2/3. I think I'm going to go and just go try my other nice numbers, and let's stick with my integers and let's try -1. So let's try 6, 7, negative 36, negative 7, and 6. Bring this down. Oops, sorry. Hold on a second. I was doing not the right one. I wanted to do the, okay, well, I know 1/2 is not going to work because it did not work in the original one, but I want to use the depressed one. Okay, so I honestly want to use this one here. Right, because that was the one I got here. So sorry, I was copying the wrong one. Okay, so I'm going to take this one, which is a 6, 19, 2, negative 3, and I'm going to try that one. So let's say I try with a -1. Bring this down 6. 6 times -1 is a -6. I add, I get a 13. 13 times -1 is a -13. I add, I get a -11. -11 and -1 is a +11. I get an 8. So at 0, I was up at 6. At -1, I'm still up at 8. So there's not going to be a necessarily 0. There could be a 0 in between there, and I just skipped over it, but not with one of these nice numbers. So let's try -3. Okay, 6, 19, 2, and -3. And I'm thinking this looks promising because when I bring this down, that's going to give me a -18. When I multiply, that's a 1. I get a -3. I get a -1. I get a 3. I get a 0. So I did find another nice one before I continued working on doing my fractions. So if I don't find a nice one, then I can, focus on those fractions. But now I have 6x squared plus x minus 1 equals 0. And I'm going to factor that. So let's say I'm going to do a box. And I have a 6x squared and a -1. And in this purple here, I'm going to do a diamond that would go with that. So that would be a -6x squared and a positive x. That's going to be a 3x and a -2x. So I'm going to have a 3x and a -2x. So that is going to give me 3x and 2x minus 1 plus 1. So I got a 2x plus 1 and a 3x minus 1. So here you'll see I'm going to get that positive 1/3. That was that 0 that I was saying I would have between 0, which was 6, and 1, which was a -24. So between 0 and 1, that 1/3 was that 0. Sometimes it's irrational. So don't focus on maybe trying those fractions because sometimes it might be a waste of your time. I try to usually do my integers first. This one here is going to give me a -1/2. So when I had one at -1, well, when my -1 was at 8 and my 0 was at 6, I actually had it dip back down, and I did have one at a -1/2. So let me just list the 4 answers out. I'll do it in blue. I had x equal 2. I had x equal -3. I had x equal -1/2. And I had x equal 1/3.